All right, so this screencast is about our first attempt as a class project to make a spinner. So this is a handheld fidget toy. Kids were given a specific set of guidelines they had to follow. The stock that they were given is maximum 3 inches long, maximum 1.5 inches wide, and it is 1/2 inch thick. So this student drawing is a spinner they've created. The next major part of the criteria is this center bore is just slightly under 17 millimeters. That way it can be warmed up if needed and expanded so that we can press fit a ball bearing in, and then students will be able to hold the toy in their hand and spin it. So since the student's already got a 3D model made, the next step to do is to set up all the CAM operations so that we can machine it in the Tormach mill. So if we switch from the model browser to CAM, we already have a whole bunch of different operations created. Once we're in CAM, I kind of like to start looking at things from the isometric view. So if you click on the little home button, it gives you perspective, a better perspective view of what you're working with, and it really helps once tools come into play. So first thing you've got to do is a new setup. I'm not going to click on it because I've already got one created for this project, and we've got a list of tools that are available on top of the red toolbox right beside the CNC. So all you got to do is just double check with me with what tool number is what, so that we make sure we use the right tools when setting up the machine. So if ever you want to know or want to look around, if you click on the tool library tab and you highlight local library, what we want to do is you can choose the different types of tools that we normally have. So we have flat mills, face mills, spot drills, and then we can scroll down and look at different tools that are available from our school's tool library. And if we scroll through all of these different functions, we can look at what we chose to get this job done. So the first things first, it looks a little bit silly, but it's a roughly modeled Tormach Superfly. So that's the Tormach tool holder and fly cutter. So what we choose when we do this, if I open up edit for you to look at, is the tabs always go in order. So whenever you choose a news operation, it's always the tool, then the geometry you want to machine, then the heights tabs, and the passes and linking. So tool, you hit the select button, come on over, you have all the options that are available to us. So tool number 25 is what we've got. Our geometry is the size of the stock that we're using, 3 by 1.5 inches. And then for our heights, I left everything in its normal position just because I know that it's safe and it works well. And we've got the clearance height, the retract height, the feed height, and then for what actually gets machined, you have the top height, which is the top of the stock, and the bottom height is the model top, but I've got offset it down 20 thou. That way it'll come down and make a very slight cut. Turn on our stock and face that top off. Next past that, most of you guys in the class that have seen this already, we've got a spot drill routine. So if we click on simulate, it's our tool number 2. It's going to come down and spot drill all the holes. Past that, we've got a 1/4 inch drill, which is tool number 6. And so this will go through and drill all the way through the part. That way, when we start using our 2D adaptive strategy, we don't have to worry about the cutter coming down and coming in contact with the hole and having to block it really slowly. So our first 2D adaptive is around the outside of the part. However, if you look from the front view, you'll see that it stops 100 thousandths of an inch from the bottom. That's because that's the material that's being held in the vise. Our second 2D adaptive strategy is these pocketing operations. The only thing I did different with this that had to be modified from the stock options is I changed the helical ramp diameter to 0.2 from the stock, which is almost 0.3. And the reason why I did that is because the center diameter of this hole being 17 millimeters, slightly under, and this tool being around 6 or 7 millimeters. It's actually the 5/16 cutter. I had to tighten up the circle that the tool drops down into. That way the cutter would lower into it. Otherwise, I use pretty much all the stock operations. One other thing I'll show you guys, whenever you start setting up any of your own tool paths, is the optimal load for tool number 15 is 50 thou. So keep an eye on that, because that will control how much width of cut the cutter takes. And since in a case like this, we're going full depth of cut, we want to ease up on width of cut a bit so it's not too hard on the tool. Then 2D contour will go in and clean up all the holes. And then an outside contour will go up and clean up the outside. These 4 flats are what we're going to use when we flip the part over in the vise, because we'll have material left on the bottom. And then we'll be able to dial indicate the center of this hole in order to find our XY 0. And we can touch the top of the stock to find our Z0, and then finish contouring and facing the rest of the material off. So if we just flip this back around, bring it to the home position, the last step you guys should know is that if you click on setup, you see your stock and where we have to do our setup from. So our work coordinate system is going to be from the center of the stock. And if you hit actions, you speed this up a bit, you can see how the tool comes around and will clear out all the material. That was a little bit quick. One thing to note, and I'll pause it when we get there, for the first 2 2D adaptive operations, the one that's going on right now and inside those pockets, I have 20 thou stock left around the outside of the part. That way there's material for the 2D contour to go around and clean up and make for a really nice surface finish. So this will go through and remove the majority of the material. And then the contouring operations, which are the last passes, they just go around and clean everything up. So even if you hide the actual model, what you're left with is an idea of what the actual finished machine part will look like. So that's what we've got right there. All right. So we'll have this going in class tomorrow, and then as we kind of work our way through, the rest of you guys can get started on making your own CAD models of a mini hand spinner.